Domain, the technical definition for domain is the set of all inputs. The set of all inputs. And let's do a choral response. When I say input, what variable do you think? X. Way to go. That was like 30% of you. Or maybe it was 100 and y'all are just tired. Oh, come get it. And then range would then be the set of all outputs. Yes. And when I say outputs, you think? F of X, also known as Y. Set of all outputs, which are the Y's. Okay. Again, set notation is almost identical to the inequality notation used for domain in Algebra 1. We just throw it a little bit more in just to make it a little bit more technical. So here's just a very simple example of its full name. Its government name is set builder notation, but I just say set notation. So it's usually going to have some squiggly brackets on the outside. Okay? And then those squiggly brackets really just say the set of. That's what you're reading when you see the squiggly brackets. So all x's, if it was domain, or excuse me, if it was range, we would say all y's and put a y here. And then we put this bar here that says such that, and then we actually write the domain. X is greater than 0, or sometimes it's like x is greater than 0 but less than 5, or sometimes it's just some numbers. But it often uses the squiggly brackets, and then the x, and then the bar, or the y, and then the bar. We do write domain and range different based on if it is discrete or if it's continuous. There's two different types of graphs that we're going to see. Discrete's up here. Continuous is down here. So if I said this is a discrete graph, how would you describe that? Say what? Try it again. What would be a good description for what this looks like, so that we know, like, what does it mean to be discrete? It doesn't, not that it doesn't continue. It really doesn't have to be continuous necessarily, but just that it's not connected. It doesn't need to be connected. A set of unconnected points. A set of unconnected points. Are we allowed to connect them? No, don't do that. Okay. So then if discrete is a set of unconnected points, all the ones on the bottom are continuous. For continuous, does continuous mean it continues to infinity in both directions? Do all of these continue to infinity in both directions? No, all of these are continuous, but it doesn't necessarily mean it goes to infinity. So what does it mean to be continuous then? Connected points, right, connected points. So my technical definition, I'm going to say it's either a solid line or smooth curve. Solid line or curve. And then you might want to make yourself a note there. Does not have to have arrows. It doesn't have to have arrows going to infinity. Doesn't have to have arrows. That's usually the most common mistake, is people think, oh, it continues forever. Not necessarily. Doesn't have to have, that seems redundant, arrows. All right, back to the top. Let's look at how to do domain and range for discrete. Did anyone notice this set of weird letters here, these wonky letters? These are some symbols that you're allowed to use in set notation. The one that we use most often is this guy right here, the R. When you draw it, it kind of looks like an R with an extra line, like you draw R, an extra line, and it literally just means all real numbers. Every single number in the whole entire world, as long as it's a number. But there's other ones that are used less often. Natural numbers are like the ones you can count on your fingers, 1, 2, 3, 4, 5. Integers include negatives. Rational numbers, do y'all know what a rational number is? What they include? Also fractions and decimals, right? Imaginary numbers, I'm not sure if you learned that in Algebra 1, but there are numbers that, like, square roots of negatives are imaginary. And then complex numbers, we'll get to that also. I believe that's in Unit 3. That's a number that has a real part and an imaginary part together. But again, the one we use most often is this guy right here. We'll use that probably on the bottom section where we have continuous. All right, looking at some discrete ones, I'm going to do this first one for you so you see the official way to write the domain and range in the set notation with the squiggly brackets. You're going to get real good at drawing them. Not today, though, but you will eventually. For my domain, remember my domain is the set of all inputs, which are the x's. So I'm going to open a squiggly bracket. Okay, I'm going to put x and then the bar just meaning all x's such that, and then we're just going to make a list. For discrete functions, you honestly just make a list of the x's. I'm going to write that. List. So I'm going to look at those x's and say, I just need to list these. Okay? It's not all the numbers in between these, it's just these numbers. If there's any that repeat, you don't have to do them more than once. So I don't need to write 2 and 2 again because I have it more than once. We also write them in numerical order, meaning like lowest to highest. So I'm going to say we just have the numbers 2, comma, we also have a 3, comma, and we have a 5. That is our official set builder notation. All x's such that I've got a 2, a 3, and a 5. Again, don't have to write repeats.
For a discrete function, does not follow the rules of functions. It's like you have to repeat x.
That's okay. I didn't say it was a discrete can be a function or not a function. It can just be some sort of relationship. That's a great question. Range is going to be our y values, and again, we're just going to make a list, and we're going to do it from least to greatest. Okay. So we're going to start by saying squiggly bracket, the set of all y's, such that, and list them out. What's the leastest? -8. And then we got -7, and then what is it? 0, 1, 4, 5. 0, 1, 4, 5. There you go. Close up those squiggly brackets. I'm a pro. I've done squiggly brackets for like 20 years, guys. So if yours look wonky right now. I see a lot of people sometimes just go like this because they can't do it. It just hurts your hand. Okay, now that we know domain and range for a discrete function is just making a list of the x's and y's, I'm going to have you guys try this one right here. Okay. I think we got it. Y'all think you got it? The hardest part's going to be drawing your squiggly brackets. I'm going to give you, let's say, about 1.5 minutes to do both the domain and the range. We'll start with 1.5 minutes. We might pull it down to just a minute based on, we'll see. Just the domain on your whiteboard. Just the domain on your whiteboard. Just so I can see everybody's domains. Whatever you wrote for your domain on your paper. There's also someone's erasers on the ground over there if we want to grab it with our foot. Alright, hold it up. Hold it up, hold it up, hold it up. Beautiful, beautiful. Good, 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 good. No one forgot their X. Good job. Usually I feel like people always start dropping off that X. Very nice. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Our range would be -1, 0, 1, 2, 3, 6. There is a harder way to write this one also. If you wanted to write it more difficult, you could actually say, for this one, you could say integers, which would be which symbol up here? Z, between 1 and 6. You'd have to use inequalities. But isn't that worse? That's worse, but it's the same thing. Okay, let's look at continuous. I'm going to remind you real quick the format for how to write your inequalities, because a lot of people have forgotten this from Algebra 1. I'm going to start with domain. I don't really know where to fit this on your paper. If you got any kind of blank space on your paper, maybe on the top. Okay, so for domain, what you're going to do is you're going to put an X in the middle. Okay. And then you're going to base your inequality signs. You're always going to have inequality signs either facing or always facing to the right, but sometimes they'll have not a line underneath, like not equal to, not included, or sometimes they will be included. So for this included one, this is if you ever see a closed dot. If you have an actual closed dot, actual point there, we'll use the less than or equal to sign. If you have an open dot, or even an arrow, meaning it continues onto infinity, you'll use just the less than symbol. And then on the left-hand side, you're going to put the smallest x that you see. Smallest x. That's going to be the one that's kind of furthest to the left on your graph. On the right-hand side, you'll put the largest x that you see. That's going to be the one that's furthest to the right on your graph. Anyone remember doing this in Algebra 1? Left to right, yeah, bottom to top. Range is similar. It's just range you're looking bottom to top, which is the lowest y to the highest y. So you'll put your smallest y, you'll decide on whatever inequality symbol that you need. On the left side, you'll put smallest y. On the right side, you'll put largest y. Smallest y is going to be one furthest to the bottom of your graph, and the largest y is going to be the one furthest to the top of your graph. And that's just general format. We're also going to put our set builder notation around it, so we're going to open a squiggly bracket, x, bar, y, bar. But that's just kind of reminding you the general notation you learned for continuous graphs in Algebra 1. Ready for me to do one for you? Okay. Anyone need to refer to this? I'll keep it handy so we can look back if we need to. Okay, looking at my first graph. This is a continuous graph because it's a solid line, remember? It doesn't necessarily mean it has to go to infinity, it just has to be a solid line. I'm going to look left to right first for my domain. On the left side, I see this arrow going to the left, and I also see an arrow going to the right. So I'm going to start by opening my set builder notation, squiggly bracket, x is in the set of numbers. And then what am I going to write for my smallest x if there's an arrow? What is this? Negative infinity. Your smallest x is negative infinity. If there's an arrow, it means it's going to keep going. It doesn't mean, oh, we stop at -4. It means it continues on to negative infinity. What am I going to write for my largest x then? Am I going to write 6? No, there's an arrow, so we're going to write positive infinity on the right-hand side. We'll throw an x in between, and now we need to decide on inequality signs. On both sides, we had arrows. Which inequality sign means arrow? Just the less than, right? Just the less than, not the less than or equal to. Now, this was probably the hardest way to write it. There's an easier way to write it. The easier way, anyone know it? All real numbers. We could just said x is in the set of, and then use this guy right here, because when you say negative to positive infinity, you're literally just saying every number in the whole entire world. So we could have just said x is in the set of, and then do that r with the extra line. Okay, similar for range, but remember range is your y's. I'm going to look lowest first. Okay, lowest, what do I see? Arrow going down. Highest, what do I see? Arrow going up. Do I have to go through the whole spiel again of saying negative infinity to positive infinity, or can we just say all real numbers? We know the trick now. So we're going to say y is in the set of, and then just throw in it's a real number. Oh, sorry, can't see it. There it is. All right, First one, that one was easy. Second one, also kind of easy, but we do have some choices. We got some open dots, we got some closed dots. No arrows on this one, so we're not going to have any infinities. Let's start with our domain. They are x's. Okay, I'm going to look left to right first. Here's my leftmost x. That is at -3. And then my rightmost x is right here. It does have an open dot, but I do still want to use whatever number that open dot is on. So for my smallest x, what am I going to write? -3. That goes on the left-hand side. On the right-hand side, my largest x is 2. We'll put an x in between for domain, and now we need to decide on inequality symbols. On the left side, I have a closed dot. What symbol was for closed dot? Less than or equal to. That goes on the side with the -3. On the right side, I have an open dot, which means just less than. Perfect. Okay, let's think about range. Remember, range is lowest to highest. That's just kind of like the y-axis goes up and down. The lowest, people usually are pretty good at. Here's my lowest down here at -5. Now the highest, is this 2 right here the highest point on my graph? No, that tricks a lot of people. What is the highest place on my graph? At the top at 4. Very good. So we'll say y is in the set of numbers such that y is between, what's the lowest number again? -5. Highest number? 4. We'll put a y in between. On the side with the -5, less than or equal to? Less than or equal to. All right, here's the hard one. Let's do a thumbs up, thumbs down. On the side with the 4. Thumbs up for a closed dot, we include it. Thumbs down for an open dot, we don't include it. Is it closed or open? Closed or open? Yes, we do want to include it. Most common mistake is people say, well, I don't see an actual point there. But there is a point there. We just didn't color it in and make it super dark for you. There's points everywhere along this line, except for right here at this 2. So there is an actual point there, they just didn't darken it. So that would be less than or equal to. All right, I'm gonna have us do an ink pair share for the third one. I'm gonna give you about a minute to write both of them, and then we'll pair up and share with a partner for this guy right here, domain and range. About a minute. And then we'll pair up and share up. Brandon, bus. Sorry. Ask the driver if you could drive for him, and then just drive faster. Run every light. You got your permit, right? Yeah, you can drive that bus. It'll be fine. There's 2 different ways you could have written the domain, so maybe your yellows and pinks, purples and greens did them different. We'll see. If your partner struggled on it a little bit, you can help when needed. Acceptable answers. For the first one, what's one acceptable answer? We're living in a man's world. We gotta talk louder than that. All real numbers. You could have just said the R. Yes. X is in a set of real numbers. You could have also said that it goes from negative infinity to positive infinity if you wanted to. It's just more writing. Anyone do that one? Good. Yeah. All right, range. For our range, what was our lowest? -5. What's our highest? Infinity. We'll throw a y in between. Should we have a less than or equal to on the -5? And what about on the infinity? Is there a second way to write this one? There is. Did you do the other way? What's the other way? Yeah, you could just say y is greater than or equal to 5. Isn't that the same thing? Excuse me, -5. Isn't that the same thing? If you're going from -5 to infinity, isn't that the same thing as just going up from -5? Kind of. Just different. All right, let's flip it over. Let's see what we're doing on the... Oh my God, a word problem. What does that mean we get to do? Annotate. Annotate, and we're going to put a hashtag. The hashtag, remember, is just, what do we need to do? Hashtag, what are we doing? What is this question asking us? All right, let's go through. Let's annotate. If you ever run out of dry erase markers or highlighters, guys, I keep all the extra ones under the board up here. Sneeze. Achoo. All right, we got some variables that we're told what they represent, and then they tell us a story about a hiker and trailhead. Do y'all know what a trailhead is? It's just like the start of your hiking trail. That's all it is. Like, the lowest point on the trail is 3 meters below the sea level. So maybe this is New Orleans, and the highest point is 4 meters above. Okay, so. But our hashtag, all it's really asking us to do is write the domain and range. That's it. Write the domain and range. Let's take a minute. Let's do it. Me too. My voice is going out. This morning I woke up, I'm like, my vocal cords. All right, that's our time. Y'all ready to check? I'm just gonna have you check your own answers on this one instead of sharing. X is from -2 to 4, including both, meaning less than or equal to on both sides. The range is from -3 to 4, including both. Why did I not use open dots, even though I didn't see any actual points here? Because there's no open circle. The only time you use the less than is if you see an actual open circle or an arrow, and there's no arrows either. Okay, we got some weird ones now. Write the domain and range for each. Okay, domain should be pretty easy. Let's start with domain. We're going to do a little ink pair share on the domain. You're just going to write the domain, then we'll pair up and share. Write the domain, then we'll pair up and share. We probably only need 30 seconds to write our domain. Remember, domain is your x's, your left to right. Left to right. And there is kind of 2 different ways you can write it. 3 more seconds. All right, let's go ahead and share in our group just the domain, We'll do the range in a second. Make sure everybody got the domain. Did you do it the first way where you include the infinity, or the other way where you just say everything is bigger than this? Bird, did you share? All right, one way you could have said, oops, wrong symbol. -4 is less than x, which is less than infinity. That's one way. Or you could have just said x's are greater than 4, greater than -4. I keep forgetting the word negative. You could have just said x is greater than -4. It means the same thing. If you're saying it goes from -4 to infinity, well, that's the same as just being bigger than -4. All right, range, I'm going to have you talk about it in your group, and then I want y'all to put your final answer on a whiteboard. Let's talk about it in our group. Maybe it's weird, maybe it's not weird. Maybe it's weird, maybe it's not weird. Again, final answer on a whiteboard once you've decided in your groups. Man, some of these whiteboards are, it's like boards up, boards up, boards up. Let's see if we found it. Okay, I see some people did the double-sided. Good job. Some people just did one-sided and just said y is there greater than or equal to 1. Is it greater than 1 or greater than or equal to 1? Greater than or equal to 1. Basically just saying it's everything here and above. We could have also said 1 is less than or equal to y, which is less than infinity. Did anyone think about the fact that, like, if you were going to write down all the y's on this graph, isn't there a hole when the y is 3 right here? There's a point on the other side that kind of cancels it out. Yes. So if you were going to write down all the y's on this graph, well, you wouldn't write down 3 for this point. But for this point, it does have a y at 3, so it kind of takes over the fact that, oh, there was a hole here, so we had to jump over it, but then we didn't need it. Some of y'all probably didn't even notice that and just ignored that completely. That's going to come into play on this next one here. I'm going to have us do a table talk for the domain and range on this one. We're going to kind of work together to put together the domain and range. I think the range is the easier of the two. The domain is a little difficult. So difficult because I haven't taught you how to do it yet, but I want to see if you can come up with it. All right, let's take a couple minutes. We're going to do the domain and range for both to the best of our ability, talking about in our groups. close answers for the domain. Close. Just one tiny thing wrong with it. I saw a lot of right answers for the range. I'm going to start with range because I saw the most amount of right answers on this one. For the range, we can say it is from, there's one of two ways. You can just say y is greater than or equal to -2. That's one way. Why is it greater than or equal to and not just greater than -2 when there's an open dot here? There's closed dots right next to it. All of these are closed dots, so they kind of take over the fact that even though this one was open, all of these are closed, so they cancel it out, and we just want to say equal to. You could have also said this with the double-sided inequality. -2 is less than or equal to y, which is less than infinity. Now, before we write down the domain to check, what was the issue with the domain? What made it difficult to write, if you noticed that it was difficult to write? The hole in the graph. Because you can't just say, oh, it's everything smaller than 2. Because it's not everything smaller than 2. This one doesn't exist. So we can't say, oh, it's just everything smaller than 2 because of this little guy right here. Because -3, we say, -3 is not in it. There's two ways. There's an easy way and a hard way. You all figured out the hard way. That's good. Yeah. Okay. Here's what we're going to say. X is in the set of numbers such that, first off, I'm just going to start by saying that it's everything that's smaller than 2. Okay, X's that are less than 2. And I'm going to put a comma because it's not everything that's less than 2. It's also everything that's less than 2 except for what one number? -3. So I'm going to say except X cannot equal -3. So everything less than 2 except for -3. So everything less than here except for this guy. That's the easy way to write it. The harder way to write it is to kind of do the two separate parts of the graph. You could do this part of the graph first and just say everything less than 3. So X is less than 3. And then do this part of the graph. The numbers that are between -3 and 2. -3 to 2. So kind of putting two separate ones right here. I saw this group use the U. We don't need the U for this. When we get to the next page, we do need the U. The U is used in interval notation. It just says or, here or here. All right, there's set.